Okay, we are live. Let me see. Okay, so we can start in 2 minutes. Okay, we're going to start in 2 minutes, guys. The topic today will be about Haxe for JavaScript developers. And before we start, just a news. Yesterday, I received an email from the organization of the .js conference. It's a JavaScript conference in Paris. It will take place this December. It's a big one. It's I remember last time that I went, we were like 300 people, something like that. And we received a discount of 20% off on the ticket. So if you are interested, you can see inside the page that there is a link for the discount. If you can find it, you can see on our Twitter account or Facebook account, and you can find the code and the link to apply for this discount. Again, if you don't find also the social part, just drop me a line. We'll provide you the discount. So today we have Andy. He's a member of the Haxe Foundation that will introduce us in the magic world of Haxe, and he will help us to understand more this great technology. So Andy, it's completely up to you. If you have any question, write down in the chat or in the form that there is inside the page. So Andy, have fun.
Okay, thank you a lot. Thanks. Let me see. So you can see the slides, right? Let me have some configuration here. My cheat sheet. Oops. So yes, today I'm going to talk about Haxe, a language that compiles to JavaScript as well as Java, C#, PHP, C++, Python, etc. And thanks, Luca, for inviting me to talk about Haxe in this London JavaScript community online meetup. And this is my very first time presenting over a live stream, and it's pretty exciting. Consider that I live in Hong Kong, which is really the opposite side of the earth from London. And anyway, so today's topic is Haxe, and let me introduce myself a little bit more. And this is my GitHub profile. My name is Andy Lee. I'm from Hong Kong, as I've mentioned. I've completed a PhD in the School of Creative Media, City University of Hong Kong. And currently, I'm working for the Haxe Foundation, which is the organization who is maintaining the Haxe language and the tools around it. In these days, I'm busy updating the Haxe package across different Linux distros, and I'm also the maintainer of the continuous integration and the automated testing of the Haxe repository on GitHub. And I've also created some Haxe libraries and sometimes help fix bugs, and then primarily for the JavaScript target. And oops, is this better? Well, anyway. Yeah, this Haxe Foundation, the logo of it. So what is Haxe? What is the Haxe language and what makes it special? So the primary key features of it is that the Haxe code can be compiled to many different languages. From top to bottom, Haxe code can be compiled to Flash SWF files, to ECMAScript free source code, and obviously to JavaScript, which is the focus of today's talk. And then it can also be compiled to C++, to Python, to Neko, which is a VM, which is also maintained by the Haxe Foundation. And then it can be compiled to PHP, Java, and C#. And yes, it can basically target everywhere. It's impressive that I don't think there is any other programming language can be as portable as Haxe. So just to show you that I'm not telling lie, it's all true. It's not, well, something hypothetical. I'm to give you a little demo of comparing a little hardware program to different language. So I use Sublime Text, and I've already have a empty folder there, which I want to, well, create some Haxe code there. So first of all, as programs are saved in a .hx file, just like JavaScript files and with .js, we use the .hx extension. Here is the file, not that panel. Basically, it's a very, very simple hardware program. As you can see, the syntax is very near to Java. And you can first observe that there is class, and then there is a class method, static function, and then the main entry point is main, just like C and Java. And then the trace function is just like print9, and it will print out the statement inside the function. So how to compare it? And basically every Haxe project use a special configuration file, which I'm just going to create it. Let's call it build.hxml. It's not really XML, but it has markup language. So that's HX and then ML. So it is basically some command line argument. We are going to specify that, well, the main entry point of our program is the test class, which we have just created. So main test. And then we're going to tell it, well, we are going to compare it to JavaScript. So -js and then the JavaScript file name, let's call it test.js. And save it. And then in Sublime Text, we can use some shortcut to compile it, which is Control B. And instantly, we can see that, well, there is the results file created in the folder. Just take a look at it side by side. So pretty straightforward. Everything is wrapped around inside a top level closure. And then we can see that the test class is compiled as a closure again, and then we attach a main function there. From there, we use trace, which is compiled to console log in JavaScript. Pretty straightforward. And then finally, we call that main function, test.main. And then all is trivial and straightforward. So I won't run the JavaScript file in HTML, but well, it's obviously it will work. It will log the statement in the console panel. And if we want to compare it to another language, we just have to modify the build.hxml file. Instead of saying that, well, we to compare to JavaScript, for example, we can let it compile to like Python. And thus show you that it works. So Python file is ends with .py. Save it and build it. Control B, and then we can see that there is one more file there, which is the Python script. And then yeah, it's just simple and it just works. Just to show you a few more examples, Java, it will compile to a directory. So let's call it Java out, which will be a folder which contains the Java source code, Control B. And instantly we can observe there is a folder created. And then we can see that there is a test.java being created. And then from within the Java out directory, there is the source directory, which is the Java files, which is quite a lot of things. So anyway, yeah, this has, and this really works. So let's talk a little bit more on what is Haxe and what is not. And I want to give you a right impression, and I don't want to let you have a wrong expectation. And let's look at all the truth first. So yes, Haxe is free and open source. We have a public repository on GitHub. You can free to download the source code and then distribute it or use it as well for whatever reason you want. Then Haxe is a programming language that compiles to 9 different targets, no cheating. Haxe provides a set of small yet very useful data structure and APIs. For example, there are integers, there are floats, there are string arrays, and there is API for JSON, XML, HTTP requests, etc., etc., and they all work in all the 9 different targets. Haxe allows us to access native APIs or libraries. For example, when targeting the browser, we can use the DOM, and then we can use jQuery. If we target Java, we can use any .jar file. And then it's also true that if we do not use any target-specific things, for example, libraries or APIs, any Haxe code should automatically work on all targets. And let's take a look at some false impressions, some misconceptions. First one, you may think that, well, Haxe is probably a young new language since you haven't heard of it before, but this is not true. Haxe was released in 2005, which has been already 10 years. And then it's able to compile to JavaScript in 2006. At that moment, at that year, there was no TypeScript, no Dart, no ECMAScript, and no Google Web Toolkit. In fact, to the best of my knowledge, it's the first language that can be compiled to JavaScript. But at that time, well, JavaScript development wasn't as popular as nowadays, and the Haxe developers put most of the effort in its Flash target. But well, that's fine, although Flash is kind of declining. And then the Haxe developers survived because, well, Flash is not the only compilation target, and we can free move our code to deploy it on different targets very easily. And then Haxe is indeed very impressive, impressively portable, but it's not a magical program that converts existing application to different platforms. Concretely, Haxe does not allow us to use API or libraries from arbitrary targets. For example, you cannot we cannot use jQuery in the PHP target because, well, jQuery does not exist in PHP. I think that is fair, right? And then, of course, well, if you have some browser application coded in Haxe and you want to port the application to Android, for example, using the Java target, you will have to replace all the JavaScript library to the equivalent Java libraries. And then replace all the use of, for example, web workers to use Flex instead, and replace the HTML UI to the Android's UI. And what can be reused are those data models and business logics, but usually not the UIs, since they often depends on the platform. And of course, we do have some frameworks and libraries that help us to build application that works on multiple targets seamlessly. But keep in mind that the language itself do not give you this ability. And one big misconception of Haxe is that Haxe-produced program cannot be faster or better than the program written in the target language. It's just not true, because, well, the Haxe compiler can do a lot of optimization that optimize the program better than doing it ourselves. And I will talk about it more later. So yeah, it sounds interesting to compile Haxe code to different languages, but is there any practical reason to do so? Particularly, why do we compile to JavaScript, but not just code in JavaScript? Because we know that, well, JavaScript is kind of really good. It's kind of good enough for most of the cases. And then, of course, as someone who loves or at least interested in JavaScript, you must have known some good things about it. And then, of course, there are really a lot of good stuff in JavaScript. First of all, it is the only natively supported runtime in all browsers. You know, well, Flash is dying, and then all other plugins are being disabled by default in Chrome and Firefox. And JavaScript is definitely the best choice for us to do client-side scripting. And not just in browser. And with Node.js, we can write server-side or desktop application in JavaScript too. And the JavaScript language itself is kind of nice, and it has very simple C or Java-like syntax, which can be picked up by most programmers in no time. And comparing to some weird syntaxes like those of like Objective-C or Haskell or even Lisp, JavaScript is just easy. And JavaScript has first-class function and closure, which is super handy, especially if you are okay with functional programming. JavaScript has dynamic typing, which is super flexible. And then being interpreted with JIT, it means that its performance is quite acceptable in most cases. But really, if we look into JavaScript carefully in detail, we cannot deny that it's kind of weird, or we should say that it's unique. If we compare it to other languages, first of all, it uses prototype adherence, and there is no built-in concept of class or interface, at least before ECMAScript 6 or 2015. It's commonly known that it actually lives in C's clothing, which means that it works much more like those functional languages than the object-oriented ones like C or Java. And then take a closer look to comparing it to C or Java. There is no compilation process, which means there is no static typing. So there is no automatic checking on types before you load the script in the browser. It's kind of, there is less safety in this aspect. And then there is no compile time optimization. It means that when we write JavaScript, we have to think about some strange things like trying to pre-calculate numbers to avoid one-time number calculations. And sometimes we copy and paste codes instead of going to use functions for performance reason, because function call is expensive, you know. And then I've heard people trying to use variable with shorter names and then try to include less comments in JavaScript files, such that the file will be smaller, such that it will be load faster in the browser. And I'm not sure if you have ever heard of it. In fact, there is for a function with a command line that is too long, they have some performance impact. And because Nook decided to inline a function according to the test show function body length, you can read more about it in the link here, which I will post it to the event page after the talk. It's kind of crazy. Well, it just, well, kind of tell people just don't write too many comments because it has a performance impact. So my point is that, well, the code we write should be decoupled from the code that runs on a user's machine. Another thing of JavaScript is that it's kind of too flexible. It's too dynamic. It's hard to be reasoned by machines or even humans. For example, it's pretty hard to generate correct yet efficient machine code for a piece of JavaScript. And then the resolution of object fields and also for the JavaScript this keyword, this variable can be confusing to a lot of JavaScript programmers. And code organization can be non-trivial in JavaScript. Code organization can be non-trivial in JavaScript. The concept of modules are not properly defined until ECMAScript 6. In practice, we have to rely on conventions like AMD or CommonJS, and there are tons of ways to deliver or load our JavaScript files. For example, there are people argued about where should we put the script text, whether it should be in the head session or it should be at the end of the body session or whatever. And then should we concatenate all the JavaScript files to reduce network requests? There are people that support it and there are people that are against it. So there are actually famous JavaScript people like Douglas Cockford said that, well, JavaScript is the world's most misunderstood programming language. It looks so similar to C and Java. It even has Java in its name, yet they are just fundamentally different things. And who is to blame? Is it the user's fault that they just misunderstood JavaScript? Maybe. But don't you think that the language design is also responsible in the confusion? And there are other people have some even more interesting thoughts. And this Eric Elliott think that, well, JavaScript should be used in the JavaScript way. For example, we should not use classical adherence. Classical adherence is obsolete. Instead, everyone should, coding in JavaScript, should embrace prototype adherence, and then we should embrace the idea of composition instead of the classical adherence we are taught in school. So this is true, and I think it's clear to you now. JavaScript is just unique. It's not C, it's not Java. We shouldn't write JavaScript in the way we write C or Java. And people tell that, well, forget what we have learned in C or Java and just embrace the unique JavaScript way of programming. So here are the facts that we gathered. First, JavaScript is the only language one-time supported natively by browsers. Second, JavaScript is unique. It has its own best practices and ways of problem solving, which are fundamentally different than C or Java. Third, however, people usually learn C, Java, Python in school. So the consequences are there are many people being forced to give up their way of thinking when coding for the browsers. There is not much good reason other than JavaScript is being decided differently. Okay, it's totally fine if you are truly JavaScript person. If your first programming language is JavaScript and you can think fluently in JavaScript, that's fine, that's good for you. However, I would argue that this is just not the case for many people around the world, and they have to spend time to learn to how to emulate classical experience and other things they have learned in school using the JavaScript prototype objects and other JavaScript features. And then another implication is that what we have learned and coded in JavaScript cannot be easily transferred to another programming language. You know, prototype experience is just not popular among other languages. And even if you have mastered, for example, AMD and CommonJS modules, there's no equivalent things in other languages. Modules are just simple things in other languages. And then if you understand the crazy JavaScript, this variable very well, it has actually no use in any other language. But of course, to be fair, at least functional programming concepts and the compositional design are useful globally. So there is possible some very portable concept, but not the weird implementation of JavaScript. So I know you may have been thinking, well, maybe JavaScript is bad previously, but isn't JavaScript improving? For example, ECMAScript 6 and ECMAScript 2015 is pretty promising. However, I would argue that there are things cannot be fixed due to compatibility issues. And we have to remember that JavaScript is something that are deployed on all the browsers, and there are a lot of JavaScript file that is written according to the traditional way of the old spec of JavaScript. And then if we change some of the behavior of JavaScript, all the JavaScript file on the internet will suddenly be broken, and that's why we cannot change the behavior. And for example, what kind of things cannot be changed? The variable declaration statement where keyword is not block scoped and it cannot be changed. And the reason of why it's not block scoped is just because when JavaScript is first decided, they don't have enough time to properly decide it. It's managed by the JavaScript creator, really, and they cannot change it by now. And the way they introduce block scope to newer version of JavaScript is that they introduce a new expression, the let expression, but the where expression will still be not block scoped. So you know, automatic semicolon insertion is confusing, one of the most confusing feature of JavaScript. And then I won't go into the detail of it, but well, the rule of how an expression or a statement ends is just kind of complex and confusing for people, and they cannot change it because, well, it has been there for a long time and they just cannot break things. And the weird resolution of this variable is just weird and complex and still, yeah, it's a nightmare for a lot of JavaScript beginners, and they just cannot change it, and they have to introduce like the ECMAScript 6 arrow functions that will change this behavior, but the old function declaration definition will always use the weird resolution for this variable. So how can we practically use ECMAScript 6 or 2015 features? The only way we can do it is that, well, to support all the pro browser is to use some polyfills or streams, which is kind of tedious to find and maintain. And then also there are performance implications because if you have to know more things on the website, it means, well, it will increase the loading time, and then it will potentially decrease the performance. And then there is another way, which is to use JavaScript to JavaScript compiler, which is kind of funny because, well, if we resort to use compiler, well, why don't we use another language that can compile to JavaScript that has, well, just have the right variable scoping or some better syntax. We don't have the weird resolution of this in another language, and then, well, if we have to use JavaScript or ECMAScript 6 using a compiler, why don't we use another language? And also, yeah, even if you are not using ECMAScript 6, there is a good chance that you are already compiling JavaScript code, because there are popular build tools like Grunt and Gulp. They can do a lot of things to pre-process your JavaScript file before you put it up on the server. It can min-file your JavaScript file to decrease the file size and try to optimize it such that it will run faster, etc., etc. So really, it's a common practice nowadays to compile to JavaScript. And if you start to look at some other language, because, well, you know that JavaScript is, well, not going to be improved in some aspect, and just try and we can just try to go to look at other language, and we have a lot of different choices. And actually, there are 300 and more technologies that can target JavaScript. They include Microsoft's TypeScript, which incorporate static typing into the JavaScript syntax. And then we have CoffeeScript, which is kind of JavaScript with Python or Ruby-like syntax. Then there is Google Start. And then there are tools that convert, that compiles Java and C++ to JavaScript. So how to choose the good one? We have some criteria. And yeah, compile to JavaScript is good or bad. The advantage is that, well, we have an extra layer of abstraction, which means it will reduce the any kind of login, because instead of our code being only able to run in JavaScript platforms, we can, for example, if we use Java to compile to JavaScript, we can also run our code in JVM. For example, it will reduce the login. We have better code reuse, which is there is popular terms isomorphic application, which means you can use the same code on the client side and then as well as the server side. And then we can have arbitrary pre or post processing to the source code, which can incorporate optimization that can improve page loads or performance. We can embed assets like image or music directly into the JavaScript file. We can use macros, which is a powerful metaprogramming concept. However, of course, there are some disadvantage. And then first of all, well, again, it's an extra layer of abstraction. It loses a lot of benefits of interpreted language, because we cannot do a lot of crazy things during one time. It has to go through our compilation process, and the compilation process may take time. And then it could be hard to debug, because what you code is something different than what is actually deployed. And then it may have performance overhead, because, well, it's just different. And the comparison process may translate some construct that is not present in JavaScript. They have to emulate it in some way. So it may have some performance overhead there. And then it may not pair well with native libraries or APIs. So how to choose a good transcompiler language is that, well, we have to pick the ones that maximize the advantage and then minimize the disadvantage. So let's take a look at, for example, the most similar ones to Haxe is probably TypeScript in this aspect, in the aspect of comparing to JavaScript, I mean. They are both statically typed language with similar JavaScript-like syntax and features. However, I would argue that they are just different, and because, well, TypeScript is a superset of JavaScript, it's decided that way. Haxe is not. There are a lot of implications of this. For example, the JavaScript design false will remain in TypeScript. For example, the resolution of this. For example, the scoping issue of where statements and all this. For example, also automatic semicolon insertion. All this appear in JavaScript. Also appear in TypeScript. TypeScript just cannot fix them because it's decided as a superset of JavaScript. And then has used the more popular and reasonable semantics like C and Java, and the things I mentioned like automatic semicolon insertion does not present in Haxe, and actually has required you to use semicolon to end an expression. And it probably has probably resolved this variable in a sensible way, just like in Java or in C++, and etc. etc. Because we are not a superset of JavaScript. We are kind of a completely new design. TypeScript does not interested in optimizing the program in any way. It's stated in TypeScript design objectives. You can look it up on the TypeScript website and the repository on GitHub. They mentioned it. They are not interested in optimizing the program in any way. And however, has put a lot of effort in optimization. Like it will try to remove the some dead codes from your source code, and it try to do a lot of optimizations to guarantee that your code is very well optimized in code size and also in performance. People who like JavaScript will like TypeScript more because, well, you can really, if you understand JavaScript, you understand TypeScript, and then it's just a superset of JavaScript. However, people who like C or Java or even functional programming will like Haxe more because we have a lot of design that is in line with traditional OOP or functional programming, just like the popular language nowadays. It's easy to pick up. And there is a more comprehensive comparison between TypeScript versus Haxe in my blog post, and you can read about it later after this talk. And then this is a very brief summary of all the compared to JavaScript languages. The very left column, which I've already mentioned, TypeScript and actually CoffeeScript is very kind of similar. You have to use its own language to write it, and then you compare it to JavaScript. And then they do not do any optimizations respecting to code size or code performance. And those are actually kind of modern language, and they give you a lot of cool modern features. However, the compiler do not interested in optimization, and they do not do as much powerful features as Haxe. The comparison speed is quite fast, so you don't worry about comparing C++ codes in hours. It will not happen in TypeScript and in CoffeeScript. And it's really easy to interact with native JavaScript library and API. For Java, we have to go through the Google Web Toolkit, and then we use Google Web Toolkit using the Java language. and then we can use it to target JavaScript, and then, or we can use LLVM to target native code. So this is kind of a little bit more portable than TypeScript and CoffeeScript already. And the optimization output of Google Web Toolkit is kind of bad. It's kind of messy and slow if you try to look at it. And then the Java language is kind of old school, and it do not have first class function and all the fancy stuff we have in Haxe or in TypeScript. The compilation speed is kind of slow. It's just relatively. And interop with a native library or API is okay. For ECMAScript, it can compile C++ and C and other language to JavaScript. So it's kind of cool. You can just pick kind of a lot of language and then use ECMAScript to compile it to JavaScript, or you can compile to a native code too. So it's very portable. There are a lot of optimization going out there. It's good. And the compiler or language features depends on the front end. I'm not sure if you are really interested in programming in C++ or C. If you do, then well, it's good. And then interop with native libraries or API is kind of okay. It's yeah, not as good as TypeScript and Haxe, but yeah, it's okay. So Haxe I'm going to introduce is just kind of have a lot of advantage across all this area. Although it's you have to learn this Haxe language. However, you can have a lot of backend tasks. Other than JavaScript, you have PHP or Python. You can deploy your code on server side using the same code base as the client-side code base. And it does a lot of optimization. The language is more than rich, which I will introduce later. And the compilation speed is just very fast. It's very first thing that people will notice when they run the Haxe compiler. Is just very fast. And then interop with JavaScript library and API is pretty good. We have quite a few ways to do this interop. So let's take a look into the details. And as I have demonstrated at the beginning of the talk, you have already noticed that the Haxe syntax is very similar to the JavaScript or Java-like. It's very Java-like. Basically, we have a package like just like Java, and then this package is also reflected in the code organization. I mean the file structure. With this Hello World class is placed in the London.js package, then the path to the file will be London.js, and then Hello World.hx file, and then the code structure is kind of fixed. It's a sensible structure. It's not as expressive or I mean it's not as flexible than TypeScript or JavaScript, but it's a sensible structure that can be picked up very easily. And then we can see that there is a static link function as the very beginning of the program, and we have local functions just like JavaScript. And then in a function we can have function arguments, and then those function arguments can be optional. We can provide default value for a particular function argument, just like Java or C++. And then we can access the object properties using this dot notation, just like JavaScript. And then we can concatenate things using plus and the string syntax is just the same as all the other programming language. And then there is animus object, and then actually we can copy and paste any weighted JSON objects into as source code, and those are weighted syntax in Haxe. Yeah. So this function call And then yeah, everything is trivial. And then this is what the hardware program being compiled. So let's take a look. Let's compare it again. This is the source code. This is the compilation output. We compile it using command line arguments, which can be saved in .xml file, or it can be managed by an IDE. If some of you will prefer to use an IDE instead, of course. We can see that, well, for JavaScript, everything is encapsulated in a top-level closure, which is a best practice in JavaScript, such that to avoid global namespace pollution. And then we can see that, again, the class is compiled as a function object, and then the static function will be attached to the class object. And then local functions will be just, well, placed here as a JavaScript local function. And the optional arguments will be compiled as an if statement that check, well, if target is null, then target will be assigned with the default value world. And then all other things are just, well, same as the source code. And then finally, there is a call to the main function because it is the, well, main entry point of the program. Yeah, you can see that it is just, well, very easy to understand. And of course, I haven't really introduced the advanced features, so you may have wondered, well, what is the benefits? What is the, well, exciting language features? Well, I will just introduce in a second. So first of all, it adds static typing, just like TypeScript. Basically, it's the same as TypeScript in the static typing aspect. All the variables in Haxe is typed, is statically typed. For example, this word statement, this I variable being assigned with 1, 2, 3, the compiler will look at 1, 2, 3, the value, and it will instantly know that I is a variable of integer. And you can explicitly state that, well, I is an integer in this declaration, or you can just, well, leave it out and just let the compiler to figure it out for you. And then this type function is kind of a magic function that will print out the type of this variable at compile time, just to show you that, well, it will print out int. So the compiler will know that I is an variable of type integer. And of course, it's statically typed, which means that if we try to assign some string to this I variable, there will be a comparison error which say that, well, string should be integer. So we cannot make typing mistakes during comparison. Yeah, if the program can be compiled, we know that, well, is the typing is checked to be correct. And then, of course, we have some more complex types like arrays. For example, default variables is of type array of 4. And then if we access the elements inside it, the compiler will know that, well, the first element of float is just a float variable. And then, of course, we can assign, there's no problem of assigning integer variables inside the array. And then, yeah, however, if we want to assign a string to an array of float, and then we will instantly get a compilation error. Other than the static typing, there is proper support of OOP. It's kind of similar to TypeScript too, but for Haxe, we use a syntax more in line with Java and yeah, similar to Java and C++, really. And of course, we have the class keyword, and then we can declare instant properties. We can define constructor, which is we use the keyword new for that instead of constructor, or we using the point name, we use new. And then we can use the this variable to reference this instance correctly, and then it's guaranteed in that way. This is really referencing the class instance instead of whatever it could be in JavaScript. So this is popularly centralized. And then of course we have function methods, and then of course we can have optional arguments, and then we can return new objects, just as if you are coding in Java or C++. It's the same syntax. Okay. And then when using this point class, we can new it, and then we can call the method using this dot notation, and then we trace it out, and then it should be 1. And then let's take a look at the comparison output. So for this page is the source code, and then let's look at the comparison at this page. Basically, it's just kind of trivial, and this is the normal way people would emulate classical equivalence in JavaScript using the prototype object. So first of all, the class object is modeled with a function, which is the constructor of point. And then the methods are attached to the prototype object, which is normal. Okay. And then yeah, all the things are kind of trivial, but the point is that you don't have to do this translation of classical equivalence to the prototype equivalence manually. You don't have to learn it. You just do it as if you have learned C++ or Java when you are in school. You just code in the C or C++ or Java way in Haxe, and then during the compilation stage, the compiler will translate the equivalent class structure for you using the JavaScript features, and that's the point. So, and one interesting Haxe features that does not appear in, for example, in TypeScript is that there is inlining. So particularly, it is this inline keyword attached to a function, to a method or to a constructor that will inline the function body directly into the call site. Why do we want to do that? Why do we want to do this? Is that we know that actually a function call is kind of expensive, and if you try to program, if you try to build a game or some really performance critical application, you will notice that, well, we will try to minimize the function call, and this inline features will allow you to inline the method body to the call site such that you're kind of using OOP, you are kind of using functions, but at the end, there will be no class or no functions in the output. So maybe it's more concrete to take a look at the result. So what we have just added is this inline keywords. This is the compilation output. We can see that the point class is still there, but at the place that in the main function, you can see there is no new point and no method call, which is previously where p equal to new point blah blah blah, p2 equal to p the offset blah blah blah. However, when we add the inline keyword in front of the constructor and the class method, it will inline all the method body directly into the call site, such that it will save you a function call, which can be well several times faster in some cases, really. So this is again interesting. This only can be achieved when we decouple the code we write before compilation and the code we deployed on the browser. Only if we decouple them, we use a compiler, we can do this kind of magic stuff. And then another interesting feature, Neko elimination. We can be triggered using a compiler argument, DCE full, and then it will just throw away all the unused code, because here slide you can see that during the main function, the main execution of the software, it do not really call any new points or points.offsets or whatever. So actually, the code here is kind of useless, and they can just be thrown away, and we can just save a few bytes from the JavaScript file, and then we just add that DCE full compiler argument, and then the compiler will figure it out and just throw away the unnecessarily generated class object or things. And then it's just cool. You are using OOP, you are using functions, you are using method calls, but at the end, for performance reason, you can eliminate all of those automatically just using the compiler, and maybe just add some keywords, give some hints to the compiler, and the compiler will do it for you. And then this is not the end. This can be even further optimized. We can see that, finally, what we are interested in is the P2, the X variable, the X property of P2 here. And then we can see that actually the Y variable is never used. Either P-Y or P2-Y, they are not really traced out in any way, and they will just, can actually be thrown away too. And actually, the Haxe compiler is clever enough to throw away that for you too. You just have to add another compiler argument, which is -d analyzer, which is an experimental feature, which is not really stabilized yet, but it already works for a lot of cases that can do this call function scope that could elimination. You can see there is no P-Y, no Y properties involved. Yeah, so that's just cool. More language features, other than the performance optimization and the elimination, there are a lot of other good language features offered by Haxe, but not offered by like TypeScript or Dart. For example, there are a lot of functional programming stuff, just because the creator of Haxe is actually very good at functional programming, and actually the Haxe compiler is written in OCaml, which is a functional programming language. So he knows that very well. We can use array comprehension, which also appeared in ECMAScript 6, I think. We can use some functional goodies from some built-in battery-included class, which is Lambda, which are shipped inside the standard library of Haxe. There are filter or fold. If you know functional programming, we will really familiar with this utility methods. And then if you come from, for example, Haskell or Scala, then you will have very like this enum, which actually is GADT, which sorts for generalized alphabetic data type. And also there is pattern matching. So if you are with no functional programming, you will like it. If you do not know functional programming, well, you can just ignore it, and then you can just use classical OOP in Haxe. But just to show you that, well, we do have some very fundamental support of functional programming as well as OOP. So people coming from all around the world can use Haxe very easily. Another very famous feature of Haxe is compile time macros, and this counted as just one of the most powerful features among the Haxe users. And what it is that the concept is like you're building program to build programs. You are coding some program to code for you. So there's some kind of meta programming. So one use case is that for many JavaScript library, maybe you have built a few. You have some JavaScript library, and then often when you publish it, you want to attach a version field that state the version of that JavaScript library. For example, is like 1.0 blah blah blah. And then every time you want to make a new release, you have to remember that, well, you have to change that version tag manually by yourself. And then, however, if you use this kind of compile time macros, you can define a macro function, which depicted by this macro keywords in front of our stat function. From there, we can actually add compile time. We can launch a new process we call Git, and then we just can ask it to give us the current Git tag of the current commit. And then after we get the tag, we can inject that, return it as an expression that will be fed into the version property of this version class. And then finally, the output of this whole program, when it compiled to JavaScript, you can see that, well, it will be compiled into just a string literal, a string constant. So all these tedious jobs can be done during compile time. You can literally do whatever you want during the compilation. And this is just, in my opinion, is utilizing the advantage of a compiler at the maximum level. It's not like TypeScript. TypeScript is just trying to convert, trying to add static typing, some typing safety to JavaScript, but they do not do some advanced stuff like Haxe macros do. They do not do optimization, but Haxe do this all kind of fancy stuff that clearly justify the use of the compilation steps. So the features summary. So very quick summary. So Haxe is a modern language and a very fast optimizing compiler. It can remove a lot of JS weirdness. It is OOP and functional programming friendly. It justified the extra compilation step. Because an additional compilation step is kind of tedious. You have to utilize this compilation step for a lot of stuff to justify the use of it. Has produced clean and idiomatic JavaScript output. The JavaScript output is just easy to read. It is small in size and easy to debug. And actually we have source mapping too, if you know that. And that which means we can debug the Haxe code, the Haxe expression directly in, for example, the Chrome debugger using source map. you don't really have to look at the JavaScript output if you don't want. And then it has 9 different compilation targets, which means it's truly portable, and you can build truly isomorphic application. You are not tied into like Node.js if you are using JavaScript. You can just use any PHP server. You can use Java server. You can use Python server, or sometime later you want to build native app for Android or iOS. You can use the C++ target or use the Java target. That's fine. There's no lock-in. And this maximizes the code we use. Yeah. And then just take a look at what people have done using Haxe. Sorry. So Prezi, I don't know if you have heard about it, is the zooming presentation, which is it has been using Flash to do this PowerPoint-like zooming. It's like PowerPoint, but it's a big canvas that can zoom in or zoom out. And maybe you can just read it. Yeah, and then Prezi is have been experimenting to use Haxe to replace the Flash code to target JavaScript instead by the use of Haxe, and they have a pretty good article about that. You can read it. And then there are people that have created a very nice website like Neko, which is awarded with FWA. So it's a very complex and interactive kind of story website that features videos and some interactions. My internet connection is kind of slow, probably because I am broadcasting. Here we go. So this kind of complex stuff we can build in Haxe. Maybe I'll just let you browse through these works yourself later after this talk, because I'm running out of time. We also have a interactive online shop, and then there is some kind of SaaS, service as a service, that is called using Haxe, which is this one is an embeddable chat room. I can show this because it's kind of minimalistic. So there's a chat room that can be embedded onto arbitrary websites, just using some iframe tag that it will give you. And then there are people that use Haxe to build JavaScript library. For example, Web is a Haxe compiled JavaScript library for creating and manipulating 3D norms. I'm not sure if you are familiar with 3D modeling. So this is basically a 3D library. It's built in Haxe and then compiled to JavaScript, and then it's primarily the people for JavaScript people to use. Those are kind of 3D objects. And of course, there are games, and actually, games is just one of the areas that has been heavily been used on. There are lots of people going to build Haxe games, like in every week. this literally every week there is a new Haxe game being built, and you can browse around the OpenFL showcase and the FMB showcases. So what's more? Also, the Haxe community is actually very active. It's super active. There is a weekly roundup that you can follow up. It just concatenate all the Haxe news every week to be published in the blog post. And then you can follow the official Twitter account and also the hashtag. There are a lot of activity going out there. And then there is the Worldwide Haxe Conference, which is the official conference being held yearly. And then you can, if you have any question, you can ask in Stack Overflow. It's quite active there. There are a lot of members going to ask questions and then answer people's questions there. And then, of course, you can follow the activity on GitHub. Because, well, we have a public repository there. And then if you are interested, you can read more from our website, haxe.org. And then we have a browser version of the Haxe ID, kind of like Haxe ID that you can try, in the browser, which is try.haxe.org. Just to show you for a second. You can just, start coding here right away, and then it even have code completion there. That's code completion, and then if you press viewer +1, the output will be output here, which you can try. Then if you try to install it, you can use an official installer from the Haxe.org website, or it's also available in a lot of popular package manager. Like you can use Homebrew on Mac, and then you can use Chocolately on Windows, or you can use apt-get using a PPA.
Handy, we can't hear you right now.
Hello.
Now it's better, thanks.
Can you hear me now?
Yes, definitely.
Okay, sorry about that. What is the last slide you can see? I think it's...
Yeah, we have seen the last one. Yeah, exactly that one.
Okay, yeah. So... Yeah, I've talked about a different way to get Haxe. You can use installer, you can use package managers like Homebrew or Chocolately, or you can use apt-get by using a PPA on Ubuntu. And then there are a lot of ID supports there. Previously, I've just shown you I've used Sublime Text, and then it's also there is a very popular and very powerful ID that's Flash developed, although it's designed for Flash, is also can be used for Haxe. And then there is IntelliJ idea, which is kind of popular among the Haxe users nowadays. And then basically that's the end of my presentation. And let's get in touch. You can ask any question in the Google Plus event page of this broadcast, and then or you can reach me from Twitter. Yeah, basically that's it.
Thank you very much, Andy. It was very insightful. This was our first webinar. I think you did very, very good. Personally, I really enjoy your presentation about Haxe. I think if the Haxe Foundation is going to work hard on the JavaScript side, they will earn a lot of consensus around this, because what you have shown today is very insightful. Yes.
Yes, in fact, there are a lot of works have to be done on the JavaScript target, but we are working hard on it, and we really welcome all kind of people and JavaScript developers and try to contribute in Haxe too if you are interested. Yeah,
that's great. I think this even a better news than what we already know. So guys, thank you very much for giving us your basically lunchtime and follow us. Was really good. If you have any feedback about the first webinar, in particular, if you like the webinar format, please drop me a line or add a comment in the meetup page, because I would like to know more, because I have other plans in my mind to organize other webinars, and I would like to know if you enjoyed this experience. So Andy, thank you very much. Big thank you also to the Haxe Foundation. And I hope to hear you soon.
Okay, see you. Thank you. Bye-bye.
Thank you. Bye.